Gray. Oh yeah.
Did you want to announce anything, Dan or Manisha?
Project night the 16th of November, I guess.
Yes, we have Project Night 16th of November, and we're going to have our next educational event somewhere in this building. Or no, actually, it's going to be over at Steinberg Hall, Dietrich Hall. I lied, at 37th and Locust Walk, November 30th. I think we have 2 speakers lined up. Tim Gross, who used to be the organizer of this group, is going to be speaking on, I already forget the topic. And Manisha, you've lined up.
Yeah, and we also have 4 books from Azavia, which is a GIS geo work firm in Philadelphia, and we're going to be sharing a project that they've developed.
Cool. So I'm Tim. I'm an IT director here at Wharton, and we love hosting Philly Pug. I'm also one of the organizers, along with Manisha, Dan, and Sarah, who's not here. What? Micah. Oh, and Micah. Duh, sorry. I'm a horrible person, and it's been a long day. So welcome to Wharton. It's a great place to work. If you're looking for work, come find me after the meeting. That's how Micah ended up working here. He started coming to Philly Pug and then asked me about a job, and now he's working here. Jason also started coming to Philly Pug and asked me about a job and worked for us for a little while before he got a much higher paying job outside of academia that I'm sure he'll tell you about. But without further ado, please help me in welcoming Jason Rodriguez.
Everyone, thanks for joining the talk or coming to this talk. Like Tim said, I work at an insurance consulting firm here in Philadelphia. The company is called Willis Towers Watson. They're a data manager, data science, sort of stuff. Not building recommendation engines, which I'm going to talk about right now, but other things. Prior to that, I was at Wharton at Words for a year, which is great. And then prior to that, I got my PhD in neuroscience here at Penn. So I've been kind of out of Penn for a number of years. Today I wanted to talk about, I guess, a side project that's, I guess, sort of like could even be a bit of a work in progress. But it's basically to build a simple recommendation system in Python. So this is just kind of like I guess some of the back end of the recommendation system. It's a project that a friend and I did. This guy's name is Takahiro Doi. He wasn't able to make it today, unfortunately. But I hope to have kind of a discussion with you all about the recommendation system and and also about Magic the Gathering, which is the other sort of topic. So what are we recommending? This recommendation system recommends Magic the Gathering online cards. And the other person who contributed substantially to this project is a fellow named Shane Rude, who I won't point out if he's here, but he preferred to remain mysterious for some reason. But he's the co-owner of this website called cardhoarder.com, and they sell Magic the Gathering online cards. Everybody who's familiar with Magic the Gathering? All right, it seems like most people, maybe not representative sample of the United States, but I think it's like disproportionately. Does anybody know so the online game is very similar to the what's it called? To the paper card game. But first, I'll talk a little bit about Magic the Gathering online. Then I'll talk about how I tried to build a recommendation system using collaborative filtering. And then I'll talk a bit about, then I'll show some examples of show how I did that in Python. All right, and I probably have about 30 minutes or so of content. I really encourage you all to ask questions as they come up. Like I have no problem stopping, and this is a discussion that's great. So first, let me talk a bit about Magic the Gathering for like the 3 or 4 of you who maybe don't know it. But it's a game that requires. The basics of it is you're basically building a deck of cards. These cards are used then to play in tournaments or games, either online or in person. In fact, cardhoarder.com might be actively sponsor like a card Magic Gathering card playing team. That's fun. But anyway, so the basic idea of the game is that you have these cards. And I don't know how long it's been around, like 20, 30 plus years. Who knows? But the cards have cool art on them, and different cards have different attributes which make them which means that there's basically different value. And in fact, there's a really good Planet Money podcast on Magic the Gathering cards, because they basically the kind of designers of the game, who are called Wizards of the Coast, they decided, which is great, and they basically try to kind of use this like economics, principles of economics, to actually keep Magic the Gathering cards from becoming, keep it from becoming a bubble like Beanie Babies, right? Because they want to stabilize their card prices as much as possible, so that so there are some cards don't suddenly become worth thousands and thousands of dollars due to some collectors with just a lot extra change, or ones that see this as an opportunity for speculation to make money, and that would obviously kill the game because it would reduce access to people without thousands of dollars to play. So anyway, so it's kind of fun. You should definitely check out that podcast about the economic models there. And also, so Magic the Gathering Online is played very similar to the paper version of the game, so all the paper cards exist as online cards and vice versa. So the economics of it are pretty interesting. So the distribution network, the way this works is that there's a bunch of sites out there that aggregate information about Magic the Gathering, maybe like provide strategy guides, have information about like what were the most recent card decks that were played in tournaments where they won the tournament. And so they aggregate all this information, and they provide card profiles to allow you to decide which cards you want to buy. And then these are some screenshots from this website called MTG Goldfish, and it's they're I don't know what to really call them. They're kind of like they direct card traffic, the actual sales to Cardhoarder. But they have some interesting. But I really like their some of the information on their website, because it sort of makes it feel like like a stock trading sort of thing, right? You get to see the prices of this particular card, authority of the consoles. You get to see that sort of change over time. That's what this is. It represents the price. So you might decide, this is I don't know, it's high now. It's high now. Maybe I'll whatever, maybe I'll sell, or maybe I'll wait for it to dip at least before I decide to incorporate that card into my strategy. There are limitations on the game to keep you from really making money, I think, on these transactions. But it's kind of funny to see. And then, likewise, if you look up here in the right-hand corner, this is a list. This is kind of this is just a list of cards they have, and you can see that they have the price of the cards and whether or not they went up and down in value, which I think is just pretty fun. So also on this website, you see a link to Cardhoarder, which is the website that provides the data, and also, actually, I should take this moment to just do some like shameless marketing for Cardhoarder. But for example, if you have a website where you're in Magic the Gathering and you want to you're interested in having created this website and directing traffic to Cardhoarder, they offer like a 3% commission for every recommendation, sales and recommendation. And actually, also while I'm on that theme there, Cardhoarder also offers like credits, so that if you wanted to get started playing Magic the Gathering online, you should go there and check it out. They're beloved by the Reddit community, Magic the Gathering online community. So anyway, so the commercial is over. But so that's the idea. So the cards, they go up and down in value. And so the principle, the idea of the recommendation system here is to basically identify sort of which cards you would recommend to somebody who has already put these cards into their shopping basket. So that's the idea. So what is a recommendation system? So you're all probably familiar with recommendation systems like on popular e-commerce sites like Amazon. Here's an example for books that were recommended to me on that site. And so basically it's a way for basically you're trying to recommend purchases to users based on what you'd expect that they would like to buy. Typically it relies on some kind of machine learning. You don't want to necessarily go out there and, you want to make recommendations yourself. You want to learn something about your historical information about your historical sales, and then use that information to make a prediction, for what somebody would be interested in purchasing. And in this case, we basically use collaborative filtering, which is a form of instance or memory-based learning. And so the basic idea, if you think about the problem of recommending something, it's like pretty challenging. So probably predominantly, I would say that most machine learning problems or statistical learning problems are usually trying to predict some quantity, some like numeric quantity, using regression, or you're trying to do some classification problem. And probably most common is binary classification problems, where you're, in the case of like e-commerce, you might be predicting whether or not somebody actually, decides to buy the stuff in their shopping cart or something like that. But 0-1 type of consumer behavior events can be, modeled using various machine learning techniques. And those are really well defined. But but for recommendation systems, it's tough because the recommendation, the possible end result, right, is equal to the every single item, right? It's basically every single item that you have like in your inventory. So it requires, so it's like a little bit harder, I think, I don't know. So the way that people get around that is I think they use like more memory-based learning techniques where they just like look at all their histories and they either say like what customers. So they basically look at their order history and they say, okay, this person put these items in their shopping cart. They could say, okay, well, does this person look like? Does this person like remind me? Is there somebody another customer out there who has similar purchasing habits? And so, what would they want to purchase at this time that this particular user doesn't have? Like that's like one way of thinking about it. The other way that we did, so that would be like recommending items that similar customers purchased. And there's a really good example of that in this book called Collective Intelligence. It's like an O'Reilly book that I recommend. It has a fun example of identifying basically figuring out which customers are similar by looking at their individual purchase histories and then recommending kind of recommending, I guess, items that the two different users purchased that were not complementary. But the approach that we took is we really looked at we really looked at the orders and we're like, okay, what items, what are the relationships between the items purchased? So typically when people buy Magic cards, they're buying like multiple cards at a time, to basically update their deck. It's not usually a lot of like individual purchases, but they're usually like really changing their strategy. And so they're, buying sets of cards. So we decided that the most appropriate way to address this problem then was to look at each order and say like what are the relationships? Can we like basically create relationships between products based on whether or not they were included in an order? And so that's the approach we took, and it's a lot easier to do that just based on individual like pairwise relationships, and so that's essentially what we did. And so this is basically in general a form of collaborative filtering, using information about. I guess I didn't really introduce that part so much, but collaborative filtering is that process of taking, looking at customers that are taking your purchase history or something like that, and then using purchase history of one customer to predict purchase history of another customer. Yes.
Do you have access to their holding of cards so you know what their portfolio looks like?
Yeah, that's a good question. We don't really have access. We kind of know. We don't know. They report. There's some nice features on the cardholder website that allow people to report. Say kind of keep update what their deck is. That'll help them like make transactions. But it's not like explicitly part of the. It's not necessarily captured. Also, the mechanism for selling cards is not really captured. They mostly buy cards, I think, through through that portal, so they only kind of get one-way information. So yeah, that would be cool to know, but yeah, I don't. Yeah. So
it's the only place they can buy cards?
No, it's not. Yeah, so this is not the only place they can buy cards. Shane might have to reveal himself, but.
Yeah, Jason, you can like.
Did I make it worse? Let's Shane back there. Yeah. So just breaking the wrong. But my understanding is that you can buy games online. So there's a couple of mechanisms. You can buy games like actually within the game. You can buy cards within the game itself. So there's like this Magic the Gathering online, software that actually manages the mechanics of the game. There's methods for buying cards there, but then also you can. There are services like card hoarders that allow you to perform transactions kind of outside of the game, and it seems like most of the transactions are actually performed inside the game, and maybe like 10 to 20%, 30%, 10, 20%, roughly, are outside the game.
I'm sorry, outside the game?
Yeah, purchases outside the game.
There's really only two websites. Ours, Card Hoarder, and then there's MTGO Traders. Both of our websites facilitate these like sort of out-of-game transactions. Everything else is happening within the game itself, and it's happening between usually like human player accounts and these what are called bots, which are just like computer-run automated trades, kind of. So there's the vast majority of trades at this point probably happen in the game client, although for us, I think it's kind of 50-50.
For your customers, or you can execute purchases through the game client as well as outside the game client.
Yeah, so we control a bunch of accounts that do trades with customers that act as like a storefront within the game client, as well as the website.
Okay, that's the other like kind of interesting aspect to it, I think, is that you have these bots that are buying, you know, all the transactions I think are carried out through these like bots that they program, right? It's not like there's some inventory system where like, I don't know, stuff gets cleared. It's like if you put something in a shopping cart, like sort of there's like some bot that's like, you know, that, I don't know, it's sort of like another user in the game that ends up like trading the cards to you, which is kind of fun to think about. But okay, so any questions about that? Any more questions about the, yeah, go ahead.
So is there some sort of API for writing bots for buying and selling?
These are shame questions. Maybe you should just join me up here. I don't know.
We'll see. Let's have any questions.
All right.
No, so the bot software itself, there's no API within the game. So the way that these bots are written are with like screen manipulation technology, like very primitive, like literally clicking interface because there's no API. And so I'm not involved with that process, but it's very like old school, like 1990s style bots.
All right. Any more questions for me or Shane? Okay, great. As I said, all right. So again, you know, like I said, we're basically just trying to identify relationships between the cards, and so the idea here, and this is a slide that Taka put together, but we're basically trying to determine the probability distribution for a given card. You know, if that for every card that is included in order, if Ether Hub is in the same order. So Ether Hub is our example of a card. So we're basically, right, we want to just take all the orders where we had any given card. This card is Ether Hub, and then we want to know, and we basically take that little subpopulation of orders. So I don't know how many what proportion of orders have this Ether Hub card in it, but then we want to basically just so we use that as our subpopulation. Then we count the number of other cards. For card X, we count the number of occurrences within that occurred in that subpopulation. And then there's two ways of doing it. One is you can kind of normalize the data by dividing by the total number of cards in that sort of Ether Hub population, and that will kind of give you like a normalized relationship. Or you can just basically look at the relative frequency, which is what we did first. Sorry if that's like I'm not explaining it well, but anyways, that's what we did. So the idea is we're just trying to say, like, for a given card, what are the cards that are most frequently purchased with it? I think that's the simplest way of saying it. You could say, and you can calculate that both in an absolute way, or you can calculate in a relative way. We're just doing individual cards, so I think doing the absolute way is fine. So you could learn. So basically, it would be like Ether Hub occurred in 20,000 orders, and 10,000 of those orders, card X was also there, and maybe that was like the strongest relationship, where card Y was only there for 200 orders. Another way to do that is to normalize by the total by 20,000, to basically divide by 20,000, and then you could just say what's the proportion of cards of card X, what's the proportion of times that card X was purchased, given that Ether Hub was also purchased. So that's another way of doing it, but we didn't do it that way. So, all right. So now I'm going to go to the Jupyter Notebook. So now I'll just show you like some Python code that we use to do that, and it's really simple. Let's see if I can bring it up. Does anybody have questions on the setup here? No. All right. All right. So I just put this into like a Jupyter Notebook, and I didn't even trust that it would run. So so here is just a very simple Python notebook or Jupyter Notebook. Let's see. Oh God. So okay. I mean, all I'm doing here really is there's three tables. Three tables are the orders, the items within the order, and the cards. I mean, I use a pointer. You guys, text is really terrible. let me make it bigger. Yes. Yes. Is that better? Not showing a lot. Okay. All right. So what are we doing? Reading in the tables. I've just defined the SQL connection string in a function called, or in a package called order sales, and I put some other functions in there. I'll use pandas, NumPy, and iter tools, and you'll see their usage later on. So all I'm doing is merging these tables together. I haven't even reviewed whether or not all that stuff is absolutely necessary. I would just focus on maybe this line right here. So I'm going to use the collections. I'm going to use counter from collections. Does anybody know what counter does? Is anybody familiar with it? Yeah. That's what some board actually want to describe it. Joe, do you want to describe it? Eric?
It basically counts every item and returns a dictionary with counts. It's an ordered dictionary now.
Oh, really? Yeah. And so it's nice. I'll show you later on. You can just kind of update it with a new list, and then it just like adds all the things, all the elements that it's already seen. It just like increments the value. It does counting, right? And so what I'm doing here is I'm just taking this order items data set, and I'm just basically splitting it out into 3 columns. So the order ID, the card ID, and then the quantity. And then I'm just using using pandas group by to group it by the order ID, right? Because I'm basically trying to look at each order, and then I'm going to look at the cards in each within the order. So when you do that, just in case you're curious, it basically creates a data frame group by object in pandas, which looks like this. So here, this is one group, and this group shares. This is the order ID here. So they all share the same order ID. This is the card ID, and then this is the card quantity. And so this is kind of interesting to point out, but you'll notice that 4 is like a common occurrence in here, and actually for some cards that's the upper limit on purchases. So you can't purchase more than 4 of any one of these cards in one particular order, and that's like a mechanism basically to reduce speculation. So you can't go in here and say, oh, the price on some card dipped in the last 48 hours. I'm going to now buy 10,000 of these cards or whatever. You can't do that or you can't only do that at least in one order. But anyways, I'm giving people like strategies too much, right? But anyways, let's and so I don't know. Maybe I printed out a little too much of this, but we'll get there. We'll get there eventually. Just bear with me. A lot of 4s. Yeah.
Only you can go out to sell on Jupyter.
I know you can, right?
Yeah.
This is just the HTML page, though.
Oh.
Yeah. It was my conservative strategy of just using the HTML page. We'll just wait here for a little bit. Oh wow, it really is a huge. Yeah, I should have done that. Well, when it showed up the Jupyter Notebook, it just truncated it. So I'm like, this is fine. Oh. All right. Oh, this is embarrassing. There it goes. Yeah. Well, that's when I was like, yeah, that was probably a bad idea to print all that stuff out, and I just killed it. Anyways, this is great work here. Okay, so what I'm going to do now is I'm going to iterate through those groups, and those groups, they have 2 keys, name and group. So the name is going to be the actual, I guess it's the order ID in this case, and then the group is going to be basically, a data frame with all the items in that group. And then what I'm going to do here is, and so this is a little bit tricky, but I'm going to actually expand. So for each group, I'm going to use this NumPy repeat function to take the list of group IDs and then basically multiply them. I basically expand them based on by the quantity that exists in the order. Because the reason why we did this is if cards were only present in sometimes cards are only show up in one time per order. And so in that case, maybe we would basically just allow for the possibility of recommending the exact card that you already selected. You put one in your shopping cart, so now I don't know, maybe you'd want to actually just add another one of those to your shopping cart. I don't know. That was just like how based on the purchase history, so we did it that way. So that they're broken out. Also, we wanted to make sure we preserve, just the quantity of each cards in order. We could have just ignored this and looked at just like unique cards per order, but decided to do it this way. And so then what we're doing here is we're using the itertools permutations to just select all possible permutations from that expanded card set. And then that it ends up being a list. This returns a bunch of tuples. It returns tuples. Those tuples I'm calling the combinations, even though they're clearly permutations based on what this is written here. And then I'm just updating the counter based on those combinations. So now that's going to basically just go through each order, kind of expand the order into basically all the individual cards that were actually purchased in that transaction, and then randomly choose, and then basically choose all the possible pairwise combinations in order again, which is maybe not necessary, probably just done combinations, but then we're taking those pairs and then we're seeing how often those pairs, just aggregating those pairs up across all order history. And then if I convert it to a pandas dictionary, I think here it ends up just being a dictionary I'm turning into a pandas data frame. And it looks like, the result looks like this. So, I mean, it doesn't have any column names, but here are tuples of IDs, of card IDs, and then this is the count, the number of times that occurred within the full order history. And so basically the concept here, so the recommendation that you would make is you basically say, let's say that this 61188, this card was purchased 10 times in the presence of, these two cards were present in the same order 10 times. So, if this was like, the most that, so if these cards co-occurred most of the time when the 61188, was present, if this was the most common combination, then this would be the card that you recommend. I know I'm turning this into kind of word soup right now, but does anybody follow me? So we're going to use these counts are going to influence whether or not it's going to influence like how much we recommend the purchase of the recommendation of the second card.
This is if you like this, you'll also like this.
Yeah, that's necessarily, yeah. So looking at the co-occurrence of two cards in order, the number of times that they co-occur is going to be related to the strength of the recommendation for of the second card here. So yeah.
Ice cream, hot fudge.
Yeah, exactly. So let's see. And so that's all right. And then all I'm doing here is just preparing, just cleaning up the data frame. So I'm putting it in this source ID, target ID, and value. So this. So, I mean, what am I trying to do here? I mean, basically, I'm trying to create a relationship table between all the orders. Maybe I can. Is there a way to up the? Is there a way to increase the projector? Yes.
I have a question.
Sure.
For example, I don't know how many cards would be appropriate for one person or usually for one player. For example, is that possible that someone purchased card A and card C, they're more likely to purchase card B? I mean, the ones you did just, two combinations.
Yeah, right. There could be three. Yeah, that's right. It could go in either way, right? There could be, so essentially are there like more than just pairwise relationships? That's a good question. And we don't really answer. We didn't really, look into that in a lot of detail. But yeah, it's possible that if somebody bought, for example, there could be negative relationships. It's possible if somebody bought card A and card B, but they'd be less likely to buy card C. I mean, that's a distinct possibility. Could be that they're more likely to buy card C, but again, as you increase the combinations of cards, the complexity of the calculation gets more complex. Yeah.
This is great. Do you account for like the bias of the recommendation engine itself? For example, at time 0, you have to have some kind of recommendation, right? And
yeah.
Hey, you might like this. That's my option, and the person buys that, and it becomes a feedback loop.
Yeah, like what if your person said that users are real,
Yeah. I mean, I guess I mean, in the case of no cards in the shopping cart, wouldn't you just recommend the most popular cards? And that would be, but yeah, I mean, we didn't explicitly do that, but I mean, the implementation, I guess that's what I would do. I would recommend that, yeah. Is there something beyond that you're trying to get at, or?
Yeah, I guess for example, how would you discover stuff that is suitable but hasn't been purchased?
Yeah, no way of doing that. Yeah, that is the limitation of this. That's generally like a limitation of the instance and memory-based methods. It's really just subject to the data. So with regression, you can usually relate just like the components, the features of some data set, relatively independently to some endpoint, to some number, and then so you can basically make estimations for things. You can interpolate and extrapolate. But actually, for instance-based methods, you can't. I don't think you could really. There's probably ways of doing it, but I just don't know what they are. Yeah.
So couldn't you let's say there's net decking in games, right? Couldn't you just say, hey, these are some decks you might be interested in, pull a random bunch of cards or something?
Yeah, they do full deck recommendations as well. Yeah. That's always that's kind of the other way that I think that's Yeah, that's one of the things that they already do. That MTG Goldfish site definitely has like a lot of like full deck recommendations. In fact, like like which decks did somebody recently win a big tournament in? I think they're going to cut off. They're maybe not going to allow that anymore, but that's like a common way of recommending full sets. Yes.
Getting it, like he was saying, if what a card that hasn't been purchased but that's suitable, if you could get features of the actual cards and do like Hey Nearest Neighbor using the features of what the card's being described by, I think that would be a good way to do that.
Yeah. So then you're basically trying to, instead of, right, so you're taking like kind of the abstract features of that card, like, I don't know.
Non-purchases.
Yeah. That's a way of like trying to expand it. Yeah, that totally could be done. Yes.
Those.
Oh, sorry. Yeah, there's two people, right? Dan and then you. Okay.
Those values, those are order co-occurrences?
They're ordered co-occurrences.
Okay,
Yeah.
so if one order has like 4 cards instead of 1 card, that number stays the same.
That order has 4 cards.
4 cards of the same
type. No, it'll increase. It'll be larger.
So
yeah, if there's multiple. Yeah. It's based on the absolute. Yeah, it's not based on just unique cards. It's based on the actual number of quantity. Yeah.
But since you can order at most 4, do you like weight that at all? Somebody with 4 cards is only. Do they only like that card 33% more than somebody that has 3 cards? Or?
Yeah. We didn't do that. That's kind of related to multiple card kind of like we're just doing binary like 2 card assessments. That would be like a 3 or 4 card assessment. You're saying like if that person has like 3 of this card, what are they going to buy? With their 4th card. That's kind of what you're talking about, right? Because or you can like penalize based on like yeah. I don't know how to do that easily, so I didn't. But it's a good thought. We were thinking about that a lot.
Usually we do
Go on.
Usually we do a 4 rank analysis to find the most highest combination of correlation coefficient to find out probably the best combination and do the recommendation. Because I did something like this before, but the products are not card, it's other things.
Yeah. No, I'm curious. So you basically look at correlation coefficients and then use that as a recommendation?
Yes.
Okay.
And 4 rank. 4 rank means it's maybe not the correlations of 2 items, could be several items. So that maybe will increase the accuracy.
Yeah. Okay. Yeah, that's a good thing there. I didn't know that. So full rank, it's not still going to be pairwise comparisons. Full rank comparisons would be multiple comparisons of multiple cards.
Yes, they will. If they, because I use R Studio, so for these logistic regressions, there is a full rank that they can run the combination themselves for like A and B, A and C, A, B and C. Many combinations automatically. So you can find things with lowest p-value and high correlations. Then we might use that kind of combination.
Okay. Right. I think I see what you mean.
But I'm not sure. Probably Python have the same.
Yeah, I'm sure they do. Yeah. All right. Well, that's good to know. And maybe that's what we'll check out next. Thank you. Yeah. Sorry. I know. Yeah.
Recommending net decks. I guess a complication could be the variations between similar lists, like when there are different people playing the say team or energy archetype with different variations on like using the Scarab God or not.
Right. Sorry, this guy. Well. Sorry. Sorry. Just repeat that.
To talk about recommending full deck lists.
Yeah.
There's the team or energy archetype where there are like different cards that people would play while having a very similar core of cards in the deck, but then there's stuff like do they add the Scarab God and change around some things to accommodate that or not? And that can complicate it.
Sounds so complicated. Yeah, exactly. I mean, the game is really in the end, it's really complicated, right? And I don't think I could ever really do it justice.
You could argue that if the community knows about these different ways of building decks, these alternatives, then you'll see that in the purchase history. And you're just reporting the observations.
Yeah, although I'm specifically blind to that, looking at, I don't know, interactions between cards that are in your shopping cart. So, you know, I mean, once you get beyond, and that's why if you had maybe the full rank model and you're able to say, you know, get a little bit more refinement about what the actual like scenarios are, other than just like this card was in the deck or was in the shopping cart, which I think is, you know, then you'll speak more to that. But I agree with you there. That's one of the fun things about doing like the machine learning stuff in general is you don't really necessarily need to know about all the subject matter expertise in order to do some basic tasks like you recommend products. Yeah. So yes.
You might have mentioned this already, but the recommendations area, how many cards could it show at a time? Just one or?
Oh yeah, I mean, I guess it's however many you really want to. I mean, in fact, yeah, you just, I mean, really, that's all it really does. It just like ranks the cards that you would show, and then the implementation is like really messing with that. There's somebody over here, or is that you just rubbing your eye? Okay, no. All right, go ahead.
So earlier when you were talking about relative versus absolute frequency,
yeah,
I was thinking, I didn't think it through, so you can tell me if this makes sense or not. That's fine if you're making recommendations for a single card.
Yeah.
But if they've got 3 or 4 cards in their basket already, then you want the relative.
Yeah, I would think so. Yeah, it's true. Yeah, and it's easy to do. We just did. Yeah, I agree with you. That's a situation. That's exactly the situation where it would make the most sense. The one thing that gets a little funky when you do the relative stuff is that if you just cards are uncommon, comparing, you know, you want to make sure that you can compare the cards within your shopping cart. So if there's some card that's super popular and, you know, I just imagine that there's going to be some kind of like noise when you get down to like lower cards that just don't appear that often. And you wouldn't necessarily want to, if you had like a really popular card in your shopping cart and a unpopular card, even though maybe the unpopular card is always sold or very frequently sold with some other random card, you still might want to recommend, you know, the more popular ones in general. So, I mean, there's probably that maybe the full rank stuff is the way you get around it. Maybe there's other ways of doing it. I don't know. There's maybe some way to like do some kind of credibility weighting or something like that to get around it. But yeah, that's the thoughts. Yes.
Is the only information that you're using is what cards appear in the shopping cart?
That's it. Yeah. Or what appeared in the order? Yeah.
So you're not using things like the overall popularity of the card or anything like that in your.
That's implicitly, I think, captured in this frequent sort of strategy. But yeah, overall popularity of the card is not. It's not explicitly. Well, yeah, it's not captured.
Did you consider using other sources of information, or did you just decide let's do this a shot?
I think it would be smart based on some of the other comments that some folks made about like k-means clustering and using ways to sort of extrapolate or I don't know, interpolate. I don't know what the appropriate word would be. Yeah, I think that would be the way you do it. Is you look at some other factors that are more generalizable that you can generalize between cards. But yeah, this is just no generalization. This is what we observed. All right, and then yeah, so we did this, and yeah, and this is just like, you know, showing all the, I think everyone kind of gets it. We're just showing the co-occurrences of cards in the order. And then the idea is that, you know, this is an edge table. So, and you know, this is kind of like a graphical representation of the data, right? We have the nodes here, which is like the nodes would all be the cards and like the card attributes. And then there's this edge table here. This edge represents the, you know, relationships between cards. And, you know, and the funnest thing about doing this is you can make those force-directed plots, which is what I will do. I'll show you right now if I can figure out where my mouse is. Oh my God, it's up here. Okay, whatever. All right, and so let me just refresh this. So we did a little force-directed plot here to just see like what the relationships are, and I think this is kind of fun. Did you guys see that? So this, what we did here is we just use that edge and node table, and then we put a threshold, like a minimum threshold, like the co-occurrences have to occur like, I don't know, more than 300 times or something like that, or else it like tries to plot like thousands of cards, it doesn't work. And so, but anyways, this is kind of fun because so each of these points represents a card. So here, and just like the tooltips gives the card name. So crumble to dust. Nod your head if you recognize that one. Yes. And this one is super popular. Harness Lightning. Yeah. Is that a good card? Seems like really popular. So, you know, so basically these nodes represent each of the cards, and then the edges here represent the co-occurrences between cards. So if you see a thick line here, I mean, you've probably seen these plots before. but the thick line here just represents like the overall count between the cards. And I think what's kind of fun about this is you see that there are like these distinct groups, right? And at first I was like, oh, this is like a strategy, right? Like this distinct group here represents some kind of strategy. These people use this strategy. These folks have another strategy involving a different section of cards. But actually, when we looked into this a little bit, and I used Shane's subject matter expertise this actually just represents different versions of the game. So you knew this somehow from the two examples, maybe? You were shaking, you're nodding. Anyways, sorry, picking on people here. But so I think that's what's likely these little floating groups represent. And so and then you can also visually see what the recommendation system, simple recommendation system does. Is it basically just if you are this or if you have this card in your blood-stained mire in your shopping cart, then it's going to recommend. It's probably the number one recommendation is going to be collective brutality, which I think everybody can appreciate is definitely the right choice. So anyways, so that's it. And then and I think maybe and this is maybe a subject of further analysis. And if people have some ideas, it'd be awesome if you chimed in. But there's clearly some sort of structure to this big blob here, and it would be interesting to know how much information you can learn from about game strategy, stuff like that, just simply from doing something, doing some analysis of older history. So anyways, so that's 650. So that's pretty much.
They basically have a lot of the pre-built decks.
Yeah.
This is something that works well together. So if I'm going to buy a card out of pre-built decks, pretty good chance that I'm going to want the other card out of pre-built decks.
Yeah, that's true. Yeah, that might be what this is ultimately representing in some ways, like what these pre-built decks are. What's that?
That was Steve Energy. He was referring to it.
Yeah. Both of them. So. All right. Well, that's pretty much. So the conclusions are, you can. This is a very, very basic, and obviously there's more sort of room to grow for this particular project, both in terms of the sophistication of the techniques for creating recommendations, and the recommendation of full rank modeling or correlations, and yeah, that's pretty much all I had talked about. So thank you very much. Oh, Joe. Yeah.
Real quick, I'm sorry if this is much earlier. What was the total number of orders that you're actually looking at? What's that data set look like?
Oh yeah, that's a good question.
I mean, if you can just order.
I thought it was tens. Yeah, each one of these lines, represents 300. I think they were I don't know what, 40,000, tens of thousands. Yeah, and it's some substantial amount of money. Yes.
So did they have any sort of recommendations before? I mean, did you A/B test?
Oh, in terms of actually implementing this, that didn't happen. I just built. I got this far, but you could. That would be the next step, actual implementation. You would then do A/B testing to see if look at the user behavior. Does actually presenting these recommendations in this way actually lead to the purchase of cards within that recommendation? That are being recommended. That would be. And that would be obviously next step.
Value or some other goal.
Yeah, that would be really fun to do, Shane. But yeah, not. That's good. Yes.
For the machine learning component of it, was it something that would be updated every day, retrained every day, or were you able to find a way to stream data to it somehow?
Oh, yeah, that's a good question. I think that. I think it's really simple. It probably it can be very easily updated, right? Essentially, it's just really just dictionary, right? That's a counter object. So you're just throw more things at it. It is more online. You don't have to pull the whole historical data set and process the whole thing. So in that way, it's a lot easier. It's easy to update. But yeah, go on.
So for adding new purchases, it sounds like you could just because the count object just kind of But then what about aging out all data?
Yeah, that's a good question. Yeah, I have no comment. That's a good point. Yes. Yes.
I actually had a question about that, kind of updating it. Do you have data that's kind of longitudinal, maybe the rise and the fall of a card?
Yeah, no, that's a good point. Yeah, this data is like only a few months of data, so I don't know if it would be, but no, that is, I mean, that's the one critical thing, and that's totally blind, that's totally missed here, is that they do, actually back on that website, MTG Goldfish, you can kind of see that, where am I? But you can see that there's like releases of new sets of cards, stuff like that, and that drastically changes, like that impacts the price of cards, and it impacts obviously people's interest in purchasing those cards. So you wouldn't want to necessarily, a card that just got removed from the, from like it's no longer playable, recommending one of those cards be a bad idea. This recommendation system would probably still recommend it, until it got enough information, but other than, but again, that also could be something that is, so there's an indicator there that's playable. So you could also just like very easily filter out the playable cards from the thing. But maybe not the popularity unless it had something to do with, don't know. No. Yes.
Does it take into account inventory or availability?
No, not at all. No. Yeah, but I mean, I guess that probably wouldn't be an issue. You're limited to 4 cards only per purchase for most of these cards, so I don't imagine there would be a big inventory issues. Shane, what do you think?
We occasionally have holes in inventory. I think like if we ran into that, it would be in the implementation, like the UI. We just wouldn't recommend a card that was out of stock.
Yeah. I think there is like probably stock information on the data set anyway, so just a matter of filtering it out. Yes.
What if 2 cards have the same rank?
Oh, I guess just pick randomly. Yeah.
Overall.
Maybe you could do it that way. I mean, I didn't really do it. We didn't actually do it, so maybe you would just maybe the most popular of all would make sense. Yeah. Yes.
Do you know, or do you have any way of estimating how much of your purchases are speculators trying to just sell it at a higher price later versus people who actually want to use it in the game?
Yeah, so I looked at that, and as far as I could tell, based on some based on buy and sell prices, and the cards, and then looking at each user, looking at all the user history of the card purchases, it's not clear that they would be making more than like. If they had a great strategy, maybe they make $1,000 or something like that over the course of like 4 months. But it seems like most people, that's like absolute maximum like ideal conditions. So I don't really believe that people are making it. And I guess the way that I assess that is by looking at I guess I just looked at the value of their card inventory at various times and versus like the amount. I knew how much they purchased the cards for. I know how much the cards actually cost. I don't know. So there's like a maximum like deviation between those 2 prices, and I don't know exactly when they sold them or how much they sold them for. So that's obviously a complication. But I mean, just based on that rough calculation, they just can't be making that much money. But I don't know. Maybe they're smarter than I am. Which is likely. Yes.
Well, obvious next step would be to look at whether people followed your recommendation or not, and create some sort of a feedback loop.
I would guess so. I think that would be, yeah. I mean, I think probably doing the next 2 steps, I think the full rank thing sounds good. So we did start to investigate that a little bit, and we were doing some logistic regression, trying to handle that. There's like a really high correlation between some of the cards, which screwed us up a little bit. So exactly how to deal with like the point where where it's just, the cards are like, it's totally interdependent, where you can't actually do a logistic regression. We didn't quite sort that out, so that's why I didn't really do it. But that's one option. And the A/B testing, I think, would be another one. Yes, Shane.
Sorry, by full rank, are you talking about the full contents of their shopping cart and looking at?
I think, yeah, it's like basically
more cards, just the couples you're doing.
Yeah, that's the idea. Yeah, looking at a larger body.
Full rank is I think it's a parameter in the logistic regression approach. So we can just that. If you are using R, for example, x plus z, it means what's the collision of xz with y. But if you use not a plus sign, you use a times sign.
Yeah.
That's a foreign.
Yeah.
So you can adjust it.
It basically like interacts every single item with every item. So you're looking not only at like the individual contributions like of each card, I guess to the purchase of another card, but you're looking at all the interactions between between the cards that are used as sort of predictors for, that's the idea. I can't really explain it right now so well, but and so that's exactly what we tried to do then, and it just was totally just everything. Just we couldn't fit the models because we couldn't invert the matrix to just do regression. So I don't know how to do it. I guess we could use other techniques like maybe decision trees, which aren't as sensitive to it or something, but we didn't really crack that in time. Sorry, I think there's one question over here. Is that true? Nope. Okay.
Kicking your eye on the website.
Yeah, I know. I swear. Yes, please.
You mentioned recommending additional copies of a card for people like they often bought in multiples. Is that something that people would be likely to respond to as opposed to
I would guess that thing would not be a great idea, but we just did it anyways. Yeah.
If there's a card that people often buy 4 of and someone only buys 1 of it, maybe it's that they already have 3 copies.
Yeah, it's true. It could be there's good reason. It's good. Maybe they should rethink. Maybe they should rethink it though. I don't know. Maybe that's like domain expertise. Maybe someone would just be like.
The game where it doesn't make sense to have 1 of them, but it makes a lot of sense to have 2 of them.
Yeah. Yeah. Bye.
Thank you very much.
Yeah, thanks a lot, everyone, for participating.
Tim, okay.
So who in here is hiring? Lavender is hiring. We're hiring. Who here is looking for work? So if you're looking for work, come see me or Lavender. That's the goal.
So yeah, I wanted to ask you. I'm glad you mentioned it. So how do you